video to introduce this topic of the Ice Age. I suggest that for those that have a coat, that you should probably put it on, because I especially use people from the Southwest Pacific, because in this talk, people tend to get cold and the chills, so be prepared. And of course, it's been almost 12 hours. It's after dinner, and you're all wide awake, right? Hopefully. Okay. The secular scientists are keen on saying that the Bible's false. Science has disproved the Bible. So we're going to test that. They also say we can't explain many features. So we're going to test all that with the last geophysical event in Earth history, the Ice Age, and see if they're just bluffing or not. Anyway, we must define what an ice age is. An ice age is a great increase in snow and ice. Right now, 10% of the ice occurs on Greenland and Antarctica. During the ice age, it was 30%, mainly in the high and mid latitudes and in a lot of the mountains. The ice limit in the tropical mountains was down 1,000 meters, so it was a global effect. And it's the last major event in Earth history. Last major event. And we'll see if they can explain this or if we can. Anyway, I added these two slides because of a question in my ice core talk. There's actually 5 uniformitarian ice age periods. The Pleistocene, less than 2.6 million years in their time scale. Then they got all these other ones, as you see here, and here's the time of them. Late Paleozoic to the mid-Precambrian. What about those ice ages? Well, they are glacial-like features in hard rock. And I don't believe they're ancient ice ages, because you can't have ice ages occurring during the flood, especially with all the warm water. So long ago I addressed this in this book right here. Ancient ice ages are gigantic submarine landslides. In other words, they're from the flood. And some of the features you see from scratched bedrock and things can be duplicated by landslides. And I only added this at the last minute because of a question in my ice core talk. Anyway, this is the Pleistocene Ice Age. That's their jargon, or the Quaternary Ice Age. It's generally from 2.6 million years to 11,700 years before present. Now, when the Ice Age first was developed in the mid-1800s, it was actually your first assault on uniformitarianism, because we don't have ice sheets over Scandinavia, Canada, northern United States where they occurred. So it was a huge assault and a lot of controversy. And at the time they believed in only one ice age, but then suddenly they looked and they saw complications in glacial areas, and then they claimed there were 4 ice ages. For 60 years they claimed that. Everywhere they went they saw only 4 ice ages. Maybe it was 3, maybe it was 5, but generally 4. Up until 1970. But that's all changed based on deep sea cores, where they sent a core down to the bottom of the ocean, and you got about 1,500 meter core come up, and they analyzed the variables down the core. And when the variable oscillates that way, it's a glacial. When it goes this way, it's an interglacial, so forth and so on, all the way down the core. And therefore now they believe there are 50 ice ages, various intensity during the Pleistocene. So that's the status of it right now. I must back up and present, was there really an ice age? You know, when I talk to audiences about it, there's usually a fair amount of people who don't believe in the ice age. And I think they're intimidated by the millions of years that come out of this. But there are thousands of pieces of evidence for the ice age. My favorite terminal and lateral moraine is the Wallowa, in the Wallowa Mountains, northeast Oregon. A nice horseshoe-shaped moraine in northeast Oregon, and coming out from a valley, and this valley is over deepened. Glaciers that are in valleys tend to over deepen them, like fjords on the coast of the oceans, but it happens on land too. And so you have the nice lateral moraine here, small end moraine, and another lateral moraine. When you go down to the level of the lake, you can see the trees for scale. This moraine is 600 feet tall and pretty sharp looking. And it's on top of flood deposited rocks in that area of Enterprise, Oregon, which gets up in the low 90s Fahrenheit for high temperatures. And when you look at the moraines, it's typical of glacial material of rocks of all sizes mixed up in a finer grained matrix. So that area was glaciated long ago, and it would take a temperature drop of over 50 degrees Fahrenheit, or about 33 degrees centigrade in the summer to produce ice in the Wallowa Mountains that would come out in the valley. So it's far from being glaciated today, but yet the moraine is very sharp, indicating it wasn't that long ago. And then you have all these erratic boulders, and here's one of my favorite erratic boulders. It's Bubble Rock in Acadia National Park in Maine. Left that erratic boulder sitting on the edge of the cliff. And here's another erratic boulder, one of the biggest, southwest of Calgary, Alberta, Canada. It's the Okotoka erratics. It's quartzite. It's very angular, and it certainly didn't roll down, or it wouldn't be angular. The only way you can deposit this is by an iceberg during the Ice Age. By the way, an erratic boulder is a rock that outcrops, that is left on the surface, that does not outcrop in the local area. It was transported from far. Another very interesting erratic boulder is this one right here. This is about 50 miles, 80 kilometers southwest of Portland, Oregon, and about 200 miles south of the furthest extent of the ice sheet. And what's it doing out here in the Willamette Valley of southwest Oregon? And this is a special boulder. It's argillite. It's a metamorphic shale. Argillite does not outcrop in the whole state of Oregon. So where did it come from? This type of rock outcrops where I live in western Montana. And so the only way this can come out this way is by the Lake Missoula flood that came down here and flooded this area, and these were transported on icebergs and left here. And then you find all the scratched bedrock, still pretty fresh. And this is so scratched it's polished. This is in the top of the Sierra Mountains, and you can see some of the erratic boulders left in the nice glacial polish, and the striations indicating the direction of flow was this way. So these are some of the Ice Age features you find around the Earth, indicating that there was an Ice Age, and here's the general location of it right here. Practically all Canada. Just a little spot right up here in the Yukon Territory was not glaciated. And down in the northern United States. And it's interesting that in Alaska, just the mountains were glaciated. That's a major mystery of glacial science. Just the mountains are glaciated. And then the lowlands is where you find those woolly mammoths and bison and horses in the permafrost. Not in glacial ice, in permafrost. Then in Europe and Asia, these are pretty old slides, by the way, and it's been modified some. This is the general location of the ice sheet in Europe and Asia. Most of England, down like in here. There's controversy over how far it extended in western Siberia. The latest is that it probably only was down in here. And this ocean north of Norway is called the Barents Sea, and it's very shallow. Now they know that the ice occurred on the Barents Sea. So that's some modifications, but that's the general location of the ice based on thousands of pieces of information on the surface of the Earth. Can mainstream scientists explain the Ice Age? You know, some of them make it sound like just get a little cooling, presto, there's your Ice Age. but we can talk to experts. Experts have written about the Ice Age. Can they really explain it? They challenge us about the Ice Age. How do we explain it? But can they? Well, first of all, we have to know what the requirements for an Ice Age are. There are three main requirements. Cooler summers. Summers have to be a lot colder. Winters are already cold enough in most areas. In fact, it'd be a great benefit for warmer winters, because the warmer the air, the more the moisture. And you need moisture, the second requirement for an ice age, greater snowfall. But you can't get a climate change just for a season or a year. This has got to persist year after year for the snow and ice to build up to ice sheets and glaciers and ice caps and mountains. So those are the requirements. So how much cooler are we talking about? A man did a computer study, and he wanted to find out where the 1 inch line, 2.5 centimeters, were left through the summer and into the fall, and that'd be the start of your ice age. So he cooled off Canada by increments of 2 degrees centigrade. 2 degrees below normal, 4 degrees, 6. And you can see at 12 degrees centigrade below normal, his 1 inch line was only right in here, northeast Canada. But the ice was clear south of the Great Lakes. So you need a lot more cooling to get the ice to end up in the northern United States. Much more cooling. How much? Well, in Canada, to show you what would happen, before I get to the northern United States, the average temperature in summer in Canada is 10 degrees centigrade. So when he cooled it off 12 degrees to minus 2 degrees centigrade, the amount of moisture that the air can hold went down 60%, from 10 grams per cubic meter water vapor capacity to 4. In other words, you find a cooling mechanism, you dry out the atmosphere. And that is why there are over 60 theories on the origin of the Ice Age. Over 60. There's only one aspect of historical science that I can think of that has more theories, and that's the demise of the dinosaurs. There's over 100 theories on that. So this might tell you that maybe they really don't know. Anyway, let's get back to the northern United States. What would it take for the ice to end up in a city like Minneapolis, along in the periphery of the ice sheet? Well, the average high and low at Minneapolis is 70 degrees. That's the max and the min. That's 21 degrees centigrade. So, when you would, how much further down should the temperature go below 70? Well, obviously you got to go below 32 degrees Fahrenheit on average, but because sunlight is the major mechanism to melt snow, and they get a lot of sunlight in mid and high latitudes in the summer, you've got to drop the temperature way below 0 degrees centigrade. So I went to an article from the journal Quaternary Research to find out when, in the coastal areas of Antarctica, when do they get net melting in their spring? It's when the temperature rises to 14 degrees Fahrenheit. So that's a temperature drop of over 50 degrees, but I'll round it off that for Minneapolis, you'd only have to have a temperature of 20 degrees Fahrenheit for the snow to remain. That's a summer drop of 50 degrees Fahrenheit. Talk about climate change. That is climate change. I mean, the global warming we've had since 1880 is 1 to 2 degrees Fahrenheit, 1 degree centigrade globally, and half of that you can attribute to natural processes. So man has only caused about 1 degree Fahrenheit or a half a degree centigrade global warming. But I'm not going to get off on that. I can talk about that a long time. So no more about that. But anyway, where are they going to get a temperature drop of 50 degrees Fahrenheit in the summer? Well, as you can probably see, the Ice Age is actually a huge problem for them. A huge problem. So let's go to some of the experts on the Ice Age. J.K. Charlesworth. He wrote a 1,700-page book on the subject called the Quaternary Era. And he says about theories. And this included the one that they believe now called the astronomical or Milankovitch theory. He says Pleistocene phenomena that produce some good theories? No, an absolute riot of theories, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. That's not saying much, but notice the date of this. It's old, 1957. And we know so much more now. This is modern times, right? Well, let's get a quote from somewhere else. U.S. News and World Report in 1997, the whole issue was dedicated to the 18 top mysteries of science. And one of these top mysteries is the Ice Age. And this gal, Tracy Watson, said, secular science has great difficulty explaining the Ice Age. We've been chewing on the problem for 30 or 40 years, actually more like 130 to 140 years. It's a killer, it's embarrassing. The great mysteries of science. Has anyone noticed some of those other mysteries they have there? Why should males exist? Why should that be one of the top 18 mysteries of science? Because they believe in evolution. And in evolution, you should only have one sex that reproduces asexually. They can't figure out why there's a male and a female. And they spend, every year, they write books and they publish articles trying to figure out this great mystery. And guess what? That's where our worldview has evidence hands down, because it simply says God made us male and female. And a more recent one from Nature, the most widely read journal in the world, 2008, perhaps the longest standing puzzle in neuroscience is what caused the northern hemisphere ice sheets to come and go. So they really can't explain the Ice Age. It's a major mystery. It made, in 1997, it made the top 18. Okay, they have serious problems, but can we explain it? Can we explain the Ice Age? Well, we got to figure out, when did it occur in our time scale? Well, as I showed you, the striations are the scratched bedrock, polished bedrock are on the surface. The moraines are on flood rocks. And so you can place it as a transitional climate, but before we get to the present climate. So this strongly suggests that, hey, maybe the flood caused the climate change. Indeed, that is the case. But how so? Well, the flood was a gigantic volcanic event, and meteorite impacts occurred, and the fountains of the Great Deep and volcanism added all kinds of warm water to the already warm pre-flood ocean, and it would persist but wane with time. So how would all this work? Well, volcanic aerosols reflect sunlight back to space. We know that from modern large volcanoes. And but during the Ice Age, or actually during the flood, we had a huge amount of volcanism, so there'd be quite a shroud of particles in the stratosphere. And there'd be they fall out in 1 to 10 years, depending on how high in the stratosphere they are. And so they're replenished during the Ice Age, as I will get into. But there are also meteorite impacts. 700 stratovolcanoes, and these are probably post-flood, and these erupted especially during the Ice Age, reinforcing the volcanism. And Charlesworth admits this. Signs of Pleistocene volcanicity and earth movements are visible in all parts of the world. So we had a lot of post-flood volcanism during the Ice Age. And as another evidence for that, the Ice Age portion of the Greenland and Antarctic ice cores are just chock full of ash. Huge amount of ash. They claim hundreds of volcanic eruptions they detect in the Greenland ice sheet. Also, you had impacts. There's 200 claimed impacts. About 30 of them, I think, are post-flood. The most recent large one is the Chicxulub impact in the northern Yucatan Peninsula. Formed a crater 180 kilometers in diameter. And it mostly hit carbonates and sulfates. The significance about that, the sulfates will end up going up into the stratosphere, and form sulfuric acid droplets that that reflect a lot of sunlight back to space. It would cause impact winter right after the flood, meaning from the literature, they believe that this impact, which would affect the ice age, in fact, I think it jump-started the ice age, the temperatures would be greater than 26 degrees centigrade cooler for 3 to 15 years. And that possibly a cooling effect up to 30 years. And here's the references from the literature. These two references from Geophysical Research Letters. You can read about it. So with the impacts and the volcanism, we would have a instant cooling, which I believe jump-started the ice ages at that time. And here's kind of a summary of how it works. Oh, the abundant moisture came from the warm ocean, and it'd be mainly in effect at mid and high latitudes, where the sea surface temperatures would be much warmer than they are today. So with warm oceans at mid and high latitudes, with lots of evaporation, reflecting sunlight back to space from not only stratospheric aerosols, but also the top of clouds, you'd have lots of snow that fall on the cool land. That's kind of a general schematic summary of the whole thing. So you can actually, from basic meteorology, you can find more details. I'd love to be able to model this, but it's so complicated that you can't model all this. There's a guy that publishes at the International Conference on Creationism, Stephen Goldmer, who's attempted it, but he hasn't got very far. And I reviewed his paper for this up-and-coming International Conference on Creationism, and he doesn't even produce an ice age hardly. But anyway, you can determine where the major storm tracks are based on what's called the thermal wind equation. There's a relationship in that the strongest temperature differences, horizontal temperature differences, you have the winds increasing aloft. You have the strongest winds aloft. The jet stream will be right above the strongest horizontal temperature differences. Therefore, you can put some average storm tracks, which would be between the cold ice sheets and the not so cold land. So you'd have one storm track like this, and then between the colder land and the really warm ocean out in here, and have a track up like this. As it gets further out, it weakens, and then you'd have a good track in Eastern Asia and south of the Scandinavian ice sheet. But these are general, because in meteorology, it's generally chaos theory rules. So there'd be a lot of other storm tracks, but these would be the major ones based on the thermal wind equation. And then you can figure out where the areas of the highest evaporation is. They would be in areas just east of the continents where you have west to east flow, and it'd be cold, dry air coming off the continent onto the warm ocean. You'd have tremendous evaporation close to the continent, and in the Arctic Ocean, which had no sea ice, and the Arctic Ocean probably was about 75 or 20 to 25 degrees centigrade right after the flood. And so you have huge evaporation in this area. This is your high, medium, and light out in the ocean, right out here. And so based on this, you can also time it, because the timing of the ice sheet, they time it by saying each ice age is 100,000 years. If it's older than 1 million years, it's every 40,000 years. But so do we need 100,000 years? No, based on this, we can actually time it based on the cooling of the ocean. How fast does the ocean cool during the ice age? Well, there's no way to be accurate on this. So, and here's a typical northeaster storm. I'm going to skip that. And Antarctica, the coldest, the highest evaporation would be closest to Antarctica, where it has to pile up thick on Antarctica, maybe 10 meters a year early in the ice age. So how fast does the ocean cool? Well, the way you do this is that you use what's called a balance equation or a budget equation. You add up all the cooling terms and the heating terms, and you get a change in temperature, change in time. In this case, I had a change in Q, which is the the heat of the ocean. And the cooling terms are evaporation. Evaporation is about 3/4 of the cooling of the ocean. And this is by contact of cold air over warm water. That's 25%. This actually warms the ocean. That's the difference in solar radiation subtracting infrared radiation. And you get a change in temperature, change in the with time. I don't think I should have used that Q there. But anyway, so that's the heat balance. It's like in this room, turning on the air conditioner and the heater at the same time and finding out which one wins out. And you get a change in temperature, change in time in this room. And in the case of the Ice Age, it's the air conditioner that wins out. So you get the cooling of the ocean. So how much cooling? Well, that's the key. I had to assume that to reach glacial maximum, the ocean had to cool 20 degrees centigrade. That isn't quite as low as the average temperature of the ocean today, which is 4 degrees centigrade, but it's a cooling, I estimated, from 30 degrees centigrade to 10 degrees centigrade. And because these terms, the heat goes into the atmosphere, I had to include the atmospheric balance. So this becomes a very complicated calculation, which the details will be published in a new book that CMI is going to publish in about 3 to 4 months. So anyway, there's no way to be accurate, so I used minimums and maximums for these variables. And then I chose a best estimate, 500, that became 500 years, based on a 25% decrease in solar radiation caused by the volcanic ash and aerosols. So 500 years. These are rough estimates. I need to emphasize that. They're rough. I just wanted to get a ballpark estimate. Even the ranges are short. Now this is to reach glacial maximum. How thick did the ice build up? Well, we have to estimate the thickness of the ice. And there's a lot of variables that go into this. And so I use maximum and minimums. You know, some precip lands in the ocean, some lands on the land. So here's the range for the northern hemisphere I got. The best estimate was 2,300 feet. And for Antarctica, 3,900 feet. And then you have to melt it once you reach that. And the main melting is caused by solar radiation. In here. And A is the albedo, or the reflectivity of the snow. If you have a high reflectivity, you reflect a lot of it back to space. And this is the infrared cooling. That was the main variable. And so the albedo, or the reflectivity, is very crucial. And it can change. It changes daily almost with snow. Fresh snow will reflect 90-95% of the solar radiation back to space. But if if the ice crystals grow, gets a little old, it'll absorb more. But if you get dust on it, it'll absorb a lot more solar radiation. So the reflectivity is a very key variable in this. So I use maximum minimums in the equation on the melting equation for an ice or snow cover. And I got a range along the edge, the periphery. My best estimate was 70 years for the edge. The time to melt the interior was 200 years, where it's cooler, less solar radiation, so it would take a little longer to melt. So the total time for an ice age is just 700 years. We don't need 100,000 years or 40,000 years for an ice age. This is an example of sticking to the Bible and getting all the data you can and coming out with totally different results by sticking to the Bible. And here is a plot of it all. This is the average ocean temperature in centigrade 30. As it drops down to 10 degrees centigrade, in 500 years, the ice age reaches a peak, glacial maximum. And then it melts in 700 years. And The average temperature of the ocean now is 4 degrees centigrade. And because you have a lot of snow and ice, more sea ice at the end of the ice age, and stronger winds, the ocean would become cooler ocean. So that's the plot of it all. And just recently I estimated that these are postulated, in other words, an estimate of the average summer temperature and the average winter temperature. Because of the volcanic aerosols, the summers would be cooler, but the winters would be warmer, mainly because of the warm ocean and a lot of latent heat being added from storms. So you're going to have mild winter temperatures, which is exactly what would help forming a rapid ice age. But as time goes on, the summer's warm, and the winters actually get colder, even colder than today's average. And this has major implications for a lot of features you see associated with the ice age, which I'm going to talk about tomorrow. So we'll get into that more tomorrow. Oh, oops. And precipitation. This is a global annual average precipitation postulated. This is today's average right here. Early in the ice age, because of all the warm water, heavy evaporation, your annual precipitation globally is going to be a lot more. Not just on the ice sheets, but in other places that weren't glaciated would have a lot more precipitation. This has other major impacts, which I will get into tomorrow, and then when I talk about wet deserts during the ice age. But then, wrong button. But then as it gets towards the end of the ice age, you have more sea ice. You cap the evaporation. You actually get less precipitation as the ice sheet is ending right in here. And then finally, with time, it comes up to the present average. And then sea level. You can. I wrote 2 papers in the Journal of Creation on the ice sheet over Canada and the northern United States was thin. Lots of evidence. And the Scandinavian ice sheet was thin during the ice age. So they claim that when you put all that ice up there, sea level drops 120 meters to 140 meters. But we have a lot thinner ice sheets. So first of all, at the end of the flood, sea level is actually about 66 meters above today because we don't have the Greenland and Antarctic ice sheet. So it falls to about 50 meters below sea level when you add glacial maximum. And then it comes up and does that. Was there more than one ice age? You know, they started with 1, went to 4, and now there's 50. What is the evidence for more than one? Well, I'm just going to simply quote this. This is from an article in the journal Geology, titled, it's by 6 scientists from the University of Alberta in Edmonton. A single late Wisconsin Laurentide glaciation, Edmonton area and southwest Alberta. Translating, they believe in a single one, and it's in their late Wisconsin time, and it's the Laurentide glaciation, which is in central and eastern Canada and the adjacent northern United States. So they only see one ice sheet now from Edmonton, which is in central Alberta, south. And notice what they say. Glacial reconstructions commonly assume a multiple glaciation hypothesis in all areas that contain a till cover. Till is glacial debris left over. So they assume it, and they see little complications on the edge of the ice sheet because the ice sheets surge, back up, slowly move forward. And so you can have, at the edge, you can have a lot of glacial debris separated by maybe sand, more glacial debris. They count those as multiple ice ages. But that's because they assume it. But we know that one ice sheet can do all this. So in summary, the ice age was a real event not that long ago. It is a major mystery for evolutionary earth science. Noah's flood caused the transitional climate for an ice age. And by the way, the ice age is evidence for the flood. You can look at it the reverse way. The ice age lasted only 700 years. We don't need 100,000 years for an ice age. There was only one ice age. A concluding thought. The ice age is an example of what we can do with hundreds of other earth science challenges to the Bible. Now, there's hundreds of them. Now, we do have answers for a lot of them, and partial answers, but some of them we don't have answers, mainly because there's no one doing research in that area, or we don't have enough, we don't know enough. So can't expect to answer all these challenges. I know about these because I read the table of contents of about 50 earth science journals in the library to keep up with the literature. So I know about all these challenges, and I work on some of them with time. Also, I want to mention something about the time issue. Time is not a side issue, but a younger time scale sometimes is the key to solving major mysteries that have lasted over 150 years. How so? Well, they know that volcanism cools, but when you stretch all that volcanism you see in the Pleistocene to tens of thousands of years, each volcano goes up, lasts only a few years, and it's gone. In their long age scale, it doesn't mean a thing. But if we telescope all that volcanism within several hundred years after the flood, it becomes a major cooling event for the summer cooling. And by the way, I have a special reason why I don't believe in millions of years or skeptical. I was a weather forecaster for 25 years, and I ruined hundreds of or thousands of outdoor activities by predicting sunshine rained on it. Tell me again why I should trust scientists' ability to be accurate about life on Earth millions of years ago. Sometimes when I first got in the National Weather Service, we could barely forecast the weather the next day. By the way, it's a lot better now because they got better models, and you can trust them usually out to 5-6 days now. So it's gotten a lot better. So anyway, that's why I become kind of skeptical of millions of years. By the way, I think weather forecasting would be a good career for someone who wants to get into creation science, because you realize how many variables are involved, and oh, I forgot that one. Oh, you kind of have to eat a lot of crow or humble pie. So you got to keep a light. You got to be light on our ideas, which I try to do. Anyway, I want to leave you with this final verse. Your faith, this is 1 Corinthians 2:5. Your faith should not rest on the wisdom of men. That's evolution, millions of years, deep time, but on the power of God. God has the power to do it, no sweat. So that's all I have for tonight. Thank you.